So old school is like Batman and Robin. Okay? Where, how do Batman and Robin get around Gotham? They drive the Batmobile. So they got to drive on roads, right? Okay? So they've got to drive on this road, and then they've got to, Fast and the Furious Gotham drift around a corner, and then they get to where the Joker is, right? Okay? So that's Batman and Robin. That's Cartesian coordinate system. The reason it's called Cartesian coordinate system is a French mathematician by the name of René Descartes came up with it. Okay? Right? So we got that. Okay? That's old school. Today, we're going to go new school. Okay? So a new system of equations. Okay? And that new system is like Superman. Dun, da, da, da. Okay? So we still have a point. And that point is out in the space. Okay? We just now have to get there. Well, how does Superman get to a point? He flies straight there, right? So Superman is now going to fly directly to that point. That's where Lex Luthor is. Remember, think what that one was. Yeah? All right. So Superman is going to start at his Fortress of Solitude, and his Fortress of Solitude is called the pole. Okay. So it's not the origin. Bat Cave is the origin. Okay. Fortress of Solitude is now called the pole. And the distance that that point is from the pole we call r. So r is how far away the point is from the pole. But we have to have a second measurement, and that second measurement is where to go, where that distance is. Because right now, from where I'm standing, the distance from me to RT is, let's say, 10 feet? 12? 12 feet-ish? Okay, we'll say 12. Okay? Distance from, slight back, scoot back just a little bit. Good. Distance to MB is about 12 feet too, from where I'm standing right now. Right? So I can't just say R is 12, because I could be going that way, I could be going that way, I could be going out the door 12 feet. Okay, so I need a second measurement to lock it in so that I know where I'm going. So I know where, if I was Superman, okay, I would know where Lex Luthor is. Okay? And that second measurement is called theta. Okay? We bring trig into the game. And theta is measured as the angle that Superman has to aim to get there. Okay? And theta is measured off the polar axis. Red. This is called the polar axis. That's like the positive x-axis. Yes. Okay. Now, if I go counterclockwise off the polar axes, that is going to get me a positive theta. If I go clockwise off the polar axes, that is going to give me a negative theta. What does that sound a lot like? Trig and the unit circle, right? Yeah, so circular motion, we had all that stuff going on. That was all from trig, which is basically unit circle. Okay? So this point, Lex Luthor, is sitting at the point r comma theta. And theta can be in degrees or theta can be in radians. Okay. After the first couple of examples, if theta is given to you in radians, keep it in radians. Okay? If theta is given to you in degrees, keep it in degrees, kind of so that you stay kind of, however we give you the problem, that's how we want our answer. So if the problem is in degrees, answers in degrees. Problems in radians, answers in radians. Okay? All right? Just like the units, which actually is going to help us when we're going through. Okay? So let's plot some points here now. There it is. Hydrate or dihydrate? So let's plot the point 2 comma pi over 4, which is the same as the point 2 comma 45 degrees. Okay? So the first thing that I am going to do is I am going to set my angle. Okay? So usually we would tell you do the x part first, work left to right. Go left and right first, then up and down. Well, we don't have that luxury here now, so we have to set our angle first. Okay? And so I usually like to, now because my graphs are a little bit different than your graphs. Your graphs have an angle at the 45-degree angles all labeled for you. Mine, not so much. Okay? So I've got to set 45 degrees. Well, that is that one right there, or that is pi over 4. Okay? So I'm going to stay on that ray because that's where my angle is. And I'm going to go out 2 rungs. Oh, tap the brakes. Now I gotta erase that. I gotta erase that. OCD is a real thing. Okay. I have it. Because rectangular, we're not talking rectangular. Rectangular was green. I said that before. Okay. So I'm gonna go out 2 rungs. Okay. From it. So here's 1 rung. Here's 2 rungs. So there is the point 2 comma pi over 4 or 2 comma 45 degrees. Okay. The pole is Fortress Solitude, the quote-unquote origin, if you will, and then we go out 2 rungs from that.
Why does the center not have an angle of degrees?
Because it would just be black. Because if all these, here I'll show you.
Oh yeah.
Because if all of these come in,
So that's not because it doesn't show. Okay.
no, it's just because it would just be black.
Yeah.
Yep. Mm-hmm. Yep. Yep. And most polar graphs are like that because, I mean, if it's a basic polar graph, you can make like a regular X and Y axes could be a polar graph. You don't have the rungs and things like that. Okay? All right. Let's try another one. Let's try that one. Let's graph 3, 5 pi over 6. Do whatever you want. You can put it on the same one if you want. You can put it on the next one if you want. It's your notes, sister. Decisions. That's why you got the white sheet. Decisions. Okay. So where is, this color, where is 5 pi over 6? How many angles up from 180 from the far left side? 1 or 2? This one is actually 5 pi over 6. Okay, it's that one. Because these, on this particular graph, they're by 15s. Okay. So I gotta go up 2, and then I gotta go out 3. So out 3 rungs, 1, 2, and 3 rungs right there. So there is that one. Yes. So the pole is there. 1 rung, 2 rungs, 3 rungs. Okay. Same angle, but now I want to go -3. So now what am I going to do? So I'm going to go, instead of going up and to the left, you're saying I'm going to go down and to the right 3 rungs. On that same, if I were to follow along with this down that way, so now I would go 1, 2, 3 rungs, and so this point would be right there. Okay, so it's that last one now that I want to talk about. Okay, so when r is less than 0, we are going to go through the pole in the opposite direction. Yes, sir. Okay, so we could rename that same point too, right? So another name, oops, missed it. So another name for that same point would be, let me think here now. What did I want to, what was the word? Could be, is what I used. So you said 3, 11 pi over 6, okay? Or 3, 300 degrees? Nope, 330. What's another name that we could give that same point? I'll take it in degrees or in radians. What? 3 comma 690, go around a whole nother 360. Yep, we could do that, or any multiple of 360. Yep, okay. Give me another one.
3 comma negative pi over 6.
I'd love 3 comma negative pi over 6. Or 3 comma negative 30 degrees. Love it. There's one more possibility. To bring you back up to speed to think about it, we started with a negative positive, right? Negative R value, positive theta value. Then we went to a positive positive, and then we went to a positive negative. So it's got to be negative negative is the one that we're missing. So it's going to be negative 3 comma negative pi over 6. Do we agree with that? No, I don't agree with that. Because if I go negative pi over 6, I'll do this one in purple. If I go negative pi over 6, I'm here, right? But then if I go negative 3, I'm 1, 2, and 3, and I'm over here. Okay? So it can't be negative pi over 6. Negative 11 pi over 6 would be up here. And then negative 3 would be 1, 2, and 3 would be there. Negative 7 pi over 6. Or negative 3, negative 210 degrees. Because I got to get to the negative one, I've got to get to, put it in purple again, starting here, I got to get all the way back to that one, which is negative 210 degrees, or negative 7 pi over 6. Good job. Okay? So, plot that point, okay? And then find me 3 other ways to name it. So again, now we'll start it's given to you in radians, stick with it in radians. If it's given to you in degrees, stick with it in degrees. Okay? So, negative pi over 3 is 1, 2, 3, 4 right here. And then 6, oops, in that direction. Move this one. That one. And then 6 is 1, 2, 3, 4, 5. Oops, I got to go off. So I estimate that 6 is about right there, comma, negative pi over 3. It's one rung off my graph, and I can go off my graph depending upon my R value. Other ways to give that one, so I went positive, negative. So let's go positive, positive. That would be 5 pi over 3. Negative, positive, negative 6, comma, and then so I need to be on that one. Okay, well, that's going to be 2 pi over 3. Negative 6, and I need to be on that one, so that's going to be negative 4 pi over 3. Would be my 3 other ways to name that one point. Okay? Questions on that? Okay, so you understand that I have to, because if I'm going in a negative direction, I have to be on this purple dashed one, right? So that means that I have to come from here and come all the way around to there. So here is negative 3 pi over 3 would be at that way, right? And then I have to go one more negative pi. Okay? What I'd like you to do now is I'd like you to plot any radius and any angle. Okay? Plot it on yours. Rename it in the 3 different ways. And then we're going to do a little get up and move around type of thing. So once you've got your plot and your point, okay, and your 3 names, what I want you to do is I want one person from your table to get up and go that way around the room, okay, to the next table, and they're going to check it, and one person from your table to get up and go the opposite way, okay, around the room. Okay, so one person get up and move to clockwise, one person get up and move counterclockwise. Anybody care to share one with me, or that they're stuck on, they can't quite verify? What do you got? Original. 4 comma pi over 4 is what you started with. Okay, so pi over 4 is here. 4 is 1, 2, 3, and 4, so right there is my point. Okay, agree with that part so far? Okay, so then that would be 4 comma negative 7 pi over 4. Because I have to start from here, and I have to go back this way to get all the way to that one. So if I'm here on the unit circle, I gotta go from here, I gotta go all the way back around. Okay? These 2 numbers, if I take the absolute value of these 2 numbers, they have to add up to be 2 pi. Okay? Okay? That would also be negative 4 comma and negative 4 comma. So now I've got to get to that one right there. So that's going to be positive 5 pi over 4 or negative 3 pi over 4. Because again, those 2 numbers, if I just look at the positivities of them, have to add up to be 2 pi. Okay? Because again, you're going from here just to there. So you're going to here. So that's negative 3 pi over 4. Okay? That's all I got for you today. I had more, but we didn't get to it. But I'm okay with that.